Hi friends, welcome back to my channel on statistics. If you are seeing my videos first time, then do subscribe. Let's go to the topic. In the before tutorial, I give you brief introduction about goodness of it, goodness of it. Okay. Then example from chi-square distribution. This is also one test of statistics that is called Kolmogorov-Smirnov one sample statistics and two sample statistics. This is also one topic for this is generally we have three methods, that is chi-square goodness of it, then second we have Kolmogorov, then we have Anderson Darling. Okay, AD test. Now we can see what will happen in Kolmogorov-Smirnov one sample test with example also. In chi-square goodness of it test, the comparison between the observed and expected frequencies is made for a set of k groups. Okay, in chi-square test distribution we already seen how we can apply goodness of it, means we can just take a null hypothesis from this particular data coming from particular distribution, and alternative is coming from different distribution. Then we are finding observed frequencies and expected frequencies. Then we can take the difference of observed minus expected observed frequencies minus expected frequencies whole square divided by expected frequencies. Then we can take it as a chi-square statistics. Then we can get the calculated value from k minus 1 degrees of freedom here. Okay, here in Kolmogorov-Smirnov, here mainly we are dealing with empirical distributions. Okay, we can discuss. Only k comparisons are made even though there are n observations where k less than or equal to n. If the n samples observations are values of a continuous random variable as opposed to strictly categorical data, or values are of a discrete variable, comparison can be made between the observed and expected relative frequencies for each and different values. Means in chi-square distribution what will happen if we have in expected frequencies we have less than, for example I have my sample size is 10. Okay, then here what is the value of k, means number of observations, means for example I have 1 2 3 4 has my expected frequencies. I am merging these three cells because here expected frequencies are less than 5, so I am merging with these three cells. I am take it as a one cell, so here this condition will hold k less than or equal to n. Okay, the empirical distribution we already discussed. What is empirical distribution? Means probability of x less than or equal to x divides by n. Probability of it is also just like Cdf, but divides by n is extra condition. Okay, okay. The several goodness of a fit test statistics are the function of deviations between the empirical distribution function and population of CDFs listed under the null hypothesis. The function of these deviations are used to perform goodness of fit test might be the sum of squares or absolute values of the maximum deviation to namely only a few between the test. This is Kolmogorov one sample test which will be occurred in this section. So this is the brief introduction about Kolmogorov-Smirnov test. Now we can see what is the difference between CDF and empirical distribution with examples also. See here KS one sample statistic is based on the difference between hypothesized CDF f naught x and EDF of the sample defined in chapter 2. Means see here what is Kolmogorov says, means here I am denoting here dn equal to Sn of x. Sn of x means C, EDF. Okay, EDF minus f naught of x. Here f naught of x is coming from the given data. Okay, when you solve the example you can easily understand. Okay, this is all things about this is the test statistics. We are taking supremum means maximum value from the xn of x and f naught of x. F naught x is the CDF of the given distribution. Okay, in is for any reasonable measures. This is called one sample. Similar here dn contains two parts, that is called dn negative, dn positive. Here see for dn positive we have this formula, for dn negative we have this formula. Here only few things are changing, here interchange between f naught of x and s1 of x. Okay, when you solve an example you can understand easily. This is this for proofs you can refer book also. This is theorem for how you can get s1 of x, sorry dn plus and dn negative, all things also. Okay, here s1 of x means I upon n. Here this is the EDF, empirical distribution function. Okay, this is a total proof taken from this book, Anderson book also. We can check it, this proofs, this is also theorems. Mainly we are going to the example is important. Okay, see here, now we can see what is the test procedure for applying Kolmogorov means. The test statistical use of Ks statistic is a goodness of fit type of problems is obvious. Assume we have a random sample x1, x2 and so on xn, and the hypothesis, this is our my hypothesis, fx of x equal to f naught of x for all x, where f naught of x is completely specified continuous CDFs. Since Sn of x is a statistical, this is my alternative hypothesis. Okay, here I am taking two tail test. Large number of these all things also theory you can read also. This is formula, we know this. Okay, this is the test statistic for Kolmogorov-Smirnov. Okay, now this example is, but I will discuss 2-3 examples. Okay, the 20 observations below are chosen randomly from the continuous uniform distribution over here parameters are 0 and 1, recorded to 4 significant figures and rearranged in increasing order of magnitude, determining the value of dn, and test the null hypothesis that the square root of these numbers also have a continuous uniform distribution. Okay, see here, first question is, first we find dn, then we know that we need to square. Okay, y square. Okay, the null hypothesis that will square root of this number of have a continue. You can observe, you know, this result is follows beta distribution. Okay, we can see first one, this is my data. First we can observe in Kolmogorov-Smirnov means first we can arrange data in increasing order. Okay, 0.01 so this order is coming and increasing. Just you can write all values, you can observe this table. Okay, this is my x, this is given data. Okay, this is x, this is given data. Okay, after how you can get Sn of x means just take, for example, I am taking 0.01 is the lowest value means I am assigning this as a 1 divided by n. How many values I have? 20. Okay, 0.32 in 0 less than 2, probability of x less than or equal to x means 32 are included, 11 also included, so 2 by 20, like this. If I am going to the 44, I got here 3 by 20, like this. You can get up to 20 upon 20, you got one value. Okay, after Sn of x, here f naught of x is the CDF. What is the CDF formula in uniform distribution? We all know that x minus, okay, x minus a upon, what is the formula for CDF means x minus a upon b minus a, x minus a upon b minus a. Here data coming from uniform with parameters 0 and 1, so you got same values here, x also. Here x minus 0 upon 1 minus 0 is, here you got x. Okay, same values you got for f naught of x. We all know that what is the formula for dn plus v. What is the formula for dn plus means you can just take the difference between Sn of x and f naught of x with modulus. Okay, when you can take the modulus, this all value is going to the positive. This is our dn positive. What is the formula for dn negative means here you can take Sn of x, x minus epsilon, or you can take this also, I upon I minus 1 by n, I minus 1 by, take it as a, this is as a Sn of x. Okay, I upon Sn of x. Okay, then you can just take the difference between Sn of x and f naught of x, then you can get the dn negative values. Okay, dn negative values with modulus symbol, then you can get, then find the maximum value of from this data, then find the maximum value from this data, then you can take the maximum of the both data sets. Okay, here you can observe. Okay, you got dn is 0.36 as a maximum value. Okay, for what is the second part says, see the theoretical justification behind the example is follows. Let y have a continuous distribution uniform 0 1, then the distribution of f, we are another CDF is equal to the 1 for y 0 less than equal to y less than equal to, then what we say, x square equal to y, then we, this is the standard results. This follows beta distribution with parameter 2 and 1. Okay, now we can discuss one more example. This is one-sided test. So how, what will happen in one-sided test means you can just take the, this has alternative 1, this has a your alternative 2. Okay, you can do the same thing in software also, in Minitab or SPSS different. Now how to consider confidence bonds means this is the formula for confidence bond, probability of d greater than or equal to dn. This is the tabulated value equal to alpha. Then you can just, we all know that how to construct confidence band means you can take the supremum of and probability equal to 1 minus lambda confidence interval. Then you can find the maximum and minimum of confidence interval bonds. Okay, then we have determination of sample size. How we can determine sample size means this is the formula for, here C is the what, positive, any positive quantity. Okay, this is output from software. Now see, this is example related to the normal distribution. Example related to the normal distribution. See what will happen in normal distribution. See, this is my sample values. Is a random sample of 12 persons are interviewed. Estimate median annual gross income in a certain economically depressed town. Use the most appropriate test for the null hypothesis. The income data is a normal distribution. See, this is my data. Now I want to apply the Kolmogorov-Smirnov test. From this test I can just calculate the mean and mean and standard deviation for finding Cdf. Okay, after calculating mean and standard deviation, we all know that what is the standard. I need s and s1 of x. S1 of x means I upon n. I upon n. How I can get z values means I can just take the x bar, x minus mu upon sigma, x minus mu upon sigma. Okay, here my x is 6900 and mu v is, you can calculate here, mu v is 10,400. Then you can calculate standard deviation also. Here standard deviation is 2773.325. Here I got x minus mu upon sigma, I got finally minus 1.x. Then you can check the tabulated value from the tables for checking. If when you can check the tabulated value, here negative, here negative area is there, then you can get the area from here. Then you can just find the Cdf. Then you can continue same procedure just like normal distribution. Okay, this is example from the normal distribution. You can see one more example from exponential also. Okay, this is software output. You can do on Minitab also with different softwares available in market. Okay, see, this is just for exponential distributions. Okay, exponential distribution we can see example. Okay, this is my data. Test the null hypothesis that the data below also from a one parameter exponential distribution. Here we all know that what is the Cdf of exponential distribution means 1 minus e power minus lambda or theta x. 1 minus e power minus lambda x or theta x. Okay, give you something before. See here, f naught of x is 1 upon e power minus x by x bar means this is our Cdf. You can just substitute a value of x, then x bar means what, you can calculate x bar from this given data, sample data. Okay, you can calculate x bar from the sample data. You can just substitute it. This is very simple. We don't need any table values, all things also like normal distribution. How you can get z values means you can just take the Cdf 1 minus e up power minus x by mean x. This means this is inverse lambda parameter. Okay, you can just take x values and just value, then continue same procedure. Okay, this is example from the exponential distribution. Okay, you can do from different softwares also. From the next video we can discuss Anderson-Darling test. Okay, thank you for watching. If you have any queries up to now, Anderson test or chi-square test, you can, and up to now I did chi-square test and Kolmogorov-Smirnov test. Okay, Anderson test we can discuss in next tutorial. Thank you for watching.